Success comes from effort.
Okay. I got this.
The kind of standard curriculum kind of goes out the window.
You don't get it the first time, that's okay.
How does science fit with the rest of the world?
Tends to lead us away from memory work and leads us towards a comprehension of what it is we're doing.
Here at Riverview High School in Riverview, New Brunswick, our science department works a lot differently than most schools in our area or even all over Canada and the world. We have what we call essentials and extensions. So what that is 60% of our mark is made up of what we call essentials, and the rest, the 40%, is extensions. The essentials tests, we all write together, but then you have as many tries after that to get the questions right that you need. You need to get all the questions right on that test in order to pass the class. So, after you write the test, whatever questions you have wrong, you can then go to the teacher and conference with them, and they'll ask you questions and you have to respond to get them right. And then the extensions part of the mark, they're kind of questions that go above the essentials or the basic knowledge, and they are typically harder and more challenging and are made for the students who are looking to get a really good mark in the class versus the students who are just trying to pass it.
So the Essentials Extension model at Riverview High School allow us to personalize learning for a variety of kids in the same classroom.
If students are not successful the first time on the essential component of the test, they can come in for a period of time and have a second look at that work. You have to sit down and conference with the teacher, at which point the teacher is going to ask questions to elicit the real knowledge the teacher is looking for.
So the conferencing for essentials, there's a few different goals in that. One, some students know their stuff and just have a hard time writing a test. And so this is a chance for them to just talk. Can I just talk about it and show you that I know it? Do I have to write it down? It's in there, they just have a hard time writing it down on paper. The other reason for the conferences is if they don't get the content the first time, I want them to talk with their students, their friends, to try and learn it. I want them to jump on videos and learn. I want them to talk to their great uncle and find out, learn it somehow. What that also means now is when they come up to conference with me, how do I know they know what they're doing and not just parroting what their friend just told them a few seconds ago? So the conference requires a follow-up question, a question that's related and similar, but really probes to know, do you know what you're doing, or did you just kind of copy this from a friend?
When students in chemistry, for example, come in with their multiple choice question, they have the right answer now circled, but I want to know why. Why is that the right answer? And so having just circled it because their friend got D as the right answer, so they're going to circle D, doesn't wash.
It means the difference between copying from a friend and you not knowing it and learning from a friend. Those are two very fine lines, and that's great because when you teach something, you retain so much more of it than just being the learner. So it's good both for the student mentor and the student mentee.
As someone who isn't very good at taking tests, it is more difficult for me because I don't think I maybe got one essentials test right for the whole entire time. So for me, it was frustrating never getting it all right and just checking it off and being done with it. When you're learning those essentials and you're not getting them at first and you're getting help in using the internet and things like that, it helps you know where to go when you need some extra help in your university classes. So think of it as short-term pain for long-term success.
I'm trying to get my essentials. At this moment, it's giving me just a little bit of trouble. I left this one behind for a while, so I kind of forgot the concept, so I've got to reteach myself. Therefore, I got to ask some friends, look it up online, then go back.
I think the benefits are mostly that students get an opportunity to understand what is core, what is essential, what all the other ideas and thinking build upon. It's not sort of a nebulous thing where if I spend 2 hours on this little small project, then I'll do better. It sets out exactly what the priorities are. If it's just sort of what we often used to refer to as the random 60 on a test, then no one really understands walking away from the test what was in fact essential, what was core. It was just sort of a whole conglomeration of ideas, of which I hope I got 60% of them. You know, we're saying all students must understand sort of a particular competency, as opposed to just doing enough to get a stamp on the forehead that says, you know, you have a credit. Now, when essentials are well put together, you know that a student understands the basic precepts of what you're attempting to do with them just by the fact that they have the essentials.
They saved my butt in first year courses. They really did, because having the essentials makes sure that you have a strong base of knowledge. And once you're confident with that base of knowledge, then you can go ahead and think about those more difficult concepts and things like that. But in university, unfortunately, those don't exist. So when your prof is going a million miles a minute and displaying all of these really long and confusing and scary equations on his slides, you at least have that solid base of knowledge, and that's really, really helpful for keeping your confidence up in a course which makes you want to crap your pants.
For students who are struggling and they're just, you know, attempting to get what they need to get, what it also provides for them is a clear pathway to success.
It gives them security to say, no matter what happens, I know I've got the essentials and I know I'm going to pass.
For students who are looking to, you know, climb to great heights in their academics, they know what is foundational. And so I think it serves both ends of the spectrum. I would think that for a student, and I can't speak from that perspective, but I think for a student, it would be a little bit more straightforward as to what they need to know. But it also ups the bar.
That also gives us the flexibility in the extensions to really ramp it up and to do these interesting projects, perhaps, that spend some class time on projects that we might not otherwise do. Because they know they have a solid foundation, they can kind of pick their own topic and divert a little bit and spend a little bit of time doing this, that, and the other thing. It means that my exam questions and my word problems can be another level harder, because we're now dealing with the high-end kids who, you know, physics is their future, and that's what they're going to do.
I think the main idea behind the essential extension model that we use at RHS is that the process to become better at something is more important. If you are ready, willing, and able to put in the effort to expand your knowledge and improve your skill, then success will come. And I think that's the lesson we want to leave RHS students when they graduate. We hope that it teaches students that success comes from effort, and that you don't get it the first time, that's okay. You work at it, you continue to work at it, you hone your skills, you improve your knowledge, and then success comes. It might not be the day that your class is writing the test, and that's okay.
I think the other thing too is that it tends to lead us away from memory work and leads us towards a comprehension of what it is we're doing. And I mean, one of the worst things that can happen in any situation or any science situation is we have, you know, really good memorizers being rewarded and people who are not good cognitively being put at a detriment. And so I think the essentials allows our thinkers to think, and I think it allows our memorizers to more fully comprehend what it is they know.
So in the physics classes, We also have physics projects on top of the extensions part of the class. So the physics projects, you have complete freedom on choosing what you want to do with it.
The content in physics has a tendency to be very theoretical, a lot of math, a lot of theory, and that's great, and a certain group of students really like that piece. And there's a whole other group of students that are kind of more hands-on, where it bridges into the engineering side of things, where it's still physics, but I'm not necessarily going to pull out a formula for it. And engineering is a large field, and in the upper grades in high school, we really don't have a course of engineering. And so how do we bridge that gap between the theoretical of being a physicist and being an engineer? Those are two different things. And so the project is a chance to explore some of those kind of ideas, the difference between engineering and physics.
So right now I'm making battery packs for my physics project. My physics project is making lights for students in third world countries who don't have access to lights to study with. This is just a broken down light, and this is the circuit board. I think the physics projects are a good part of the course. It encourages students to find a problem and solve it, and find creative ways to solve the problem. And so I like it.
We are making a cup that doesn't spill as easy, so if you had like shaky hands, I guess, or like a tremor or something, you'd be able to drink more easily without like spilling your glass of water.
I discovered what I wanted to do, which went from doing a music degree to doing an engineering degree. In September, I started building a 3D printed prosthetic hand. It started as a physics project, and then it became so much more than that. I never thought it would blow up like it did. Like, this is the third film I'm in. I've been published in 3 countries across the world. And when I'm at work, people are like, "Are you that hand girl?" And I'm kind of like, yes. I even had a guy offer me a job just by meeting me in my line at Sobeys because of what I did while I was in high school, and I'm still continuing on with it to this very day, so it's very awesome.
So in our science department, we also have a Science 12 class. Now that class is very different from like your biology, your chemistry, and your physics. It kind of links science up with the rest of the world.
Science 12 is really meant to try and catch some of the holes that we might have missed throughout the years, and oftentimes that involves some of the soft skills and how to behave like a scientist, and group dynamics, and how does science fit with the other sciences, and how does science fit with the rest of the world.
Science 12, the kind of standard curriculum kind of goes out the window. It's more about learning how to work with other people, especially people who clash personalities with you. You do a lot of different things, like research, can we really end world hunger? And half the class was, yes, we can end it, and the other half was no. And in those groups created by Mr. Fogarty, it had a mix of people who disagreed with what they were trying to portray. So like people who said, yes, we can end world hunger, were in the no, we can't group. So that was kind of really interesting and helped open up eyes to a different point of view.
You don't have much room in your schedule for any other weird and wonderful subjects, and let alone sign up for them. But the Science 12 classes, because it's a whole variety of everything, it's an interdisciplinary project, they can behave like journalists for a couple of weeks. They can get an idea of, I like graphic arts, I like design, and I think I'm good at design. I didn't know I was good at design. I would never have taken a course in design, but because of this 3-week thing where I was doing science and design, or science and graphic arts, or science and journalism, they discover these other passions that they have.
So Science 12 projects, one, it's a lot bigger of a project. We've spent like a few months on the projects now. For Science 12, we had to pick a problem in the world and try and fix it. We were doing English and writing pitches and like going out to contests and all that kind of stuff. It wasn't just physics, it wasn't just, like, it was everything put together.
Science 12, the project in that was more dedicated to actually solving a real solution in the world.
So for Science 12 and physics, we decided that we were going to make a new beehive. So we took an old concept for a beehive that's made in Africa, in Kenya to be more specific, and we altered it and put a heating system on it so that it could stay heated, so that during the winter it could stay warm, and in the summer it can cool down, so that instead of fanning their hive they can go get more honey and stuff, so it's a more productive beehive.
We have gone to 3 shows, one being Sustainapalooza and the other being YEC presentations, Youth Entrepreneurship Challenge, and we presented and pitched our idea, and we were ultimately awarded with $1,500.
Science 12 kind of really helps you learn how to work with people while learning how to view the world in a different way, which is really cool.
It's as much a measurement tool for me as an educator as it is for a learner.
You really, as a teacher, get to find out exactly where the misunderstanding, the misconception lay for that individual student.
Once it's rolling, it plays very nicely.
What does Science 12 do?
That's a good question.